Hi guys, welcome to BRE. My name is Boston and today we're going to be reading The Earth by Arthur Beiser. The Earth by Arthur Beiser. Today we're going to be reading page 20 to page 21. Human explorers on the moon are learning much about the nature of matter in space, and thus about the history of our own planet. Other sorts of clues have been available for some time. These come from studies of chunks, lumps, fragments, and specks of dust that continually rain down upon the Earth from outer space. Not long ago, many people believed that the brief flashes in the night sky that we now know are meteor trails were somehow involved with the atmosphere and with the weather in general. Meteor, from which we get our word meteorology, comes from the Greek for high in the air. There was logic in such a view, but it was based on the inaccurate assumption that lightning bolts produce something called thunderstorms, which were actually particular rocks, or more often the crude, unrecognized flint of tools of early man. Meteor flashes, too, were sometimes accompanied by thunder sounds and unidentifiable fragments of stone or iron. Even with today's understanding, the matter of meteors still involves complex languages. Specialists are very careful to distinguish between meteoroids, the bits of matter regardless of size or composition, that drifts through space. Meteors, the flashes lights produced by the meteoroid as it is heated, glowing hot by its passage through the Earth's atmosphere. And finally, meteorites, the fragments ranging from dust to huge rocks that survive the Fury passage and reach the Earth. Meteorites are the only samples of material from space that men can now study. As a result, meteorites are fascinating to students of the Earth, as they are to astronomers. Meteorites are the three general classes. Irons compose 98% or more of nickel iron. Stony irons composed roughly half and half of nickel iron, and the kind of rock known as olivine. The finally stones all offer useful clues to the history of the Earth, for not only are meteorites fellow members of the solar system, but they are probably as old as the Earth itself. A few spectacular falls have brought irons weighing as much as 30 tons or more smashing into the earth. But aside from these, a vast amount of meteoric dust continually falls from the heavens, perhaps as much as several million tons every year. This dust consists of tiny particles ranging in size from a 10,000th to a 100,000th of an inch across. Meteorite dust particles have been found around the world, and because many of them contain iron, they may be extracted magnificently from rainwater. Many meteor showers occur in strings with established orbits. Some of these orbits are known to be the same as orbits of former comets. Therefore, one might suppose that meteor showers represent the debris left in the wake of comets, past or present, but it is doubtful that such comet dust meteors are ever large enough by the time they reach the Earth's surface to be studied. The particles are so small that by the time they are burned in the atmosphere, there is almost nothing left. Many scientists feel that meteors that do not reach the Earth as meteorites are fragments of asteroids. A belt of these objects orbits the Sun between Mars and Jupiter. It is likely that many meteorites were once asteroid fragments that were knocked from their paths into orbits that brought them within the field of the Earth's gravitational pull. But whatever their source, the meteorites that have fallen and continue to fall to the Earth, and that in the past marked the moon, offered tantalizing clues to the composition of those interior parts of our planet that lie beyond reach, and clues to the Earth's origin as well. Okay guys, that's it for today. See y'all next time on BRE. Bye.